Our 7th lecture video on work, power, and energy will cover the topic of conservation of mechanical energy. The law of conservation of energy states that the sum of the kinetic energy and the potential energy in a system is constant if no resistant forces do work. In other words, in a closed system, energy is neither created nor destroyed, it just changes forms. When looking strictly at mechanical energy, kinetic energy can be converted to potential energy and vice versa. The potential energy of an object above some reference level is equal to the kinetic energy of the same object just before it hits the ground. We can say that the maximum kinetic energy is equal to the maximum potential energy. In other words, 1/2 mass times velocity squared is equal to the mass times acceleration due to gravity times height. Since the mass of an object is the same and won't change, the mass cancels off and we are left with 1/2 the velocity squared equals acceleration due to gravity times height. We can solve this equation for v to find the velocity of an object according to the law of conservation of energy. The velocity is equal to the square root of 2 times the acceleration due to gravity times the height. We can look at the idea of conservation of mechanical energy another way. The potential energy of a skier at the top of the hill when they are standing still is equal to the kinetic energy of the same skier at the bottom of the hill. We could also say that the kinetic energy of the skier at the bottom of the hill is equal to their potential energy at the top of the hill. If that same skier is originally moving at the top of the hill, or they are initially in motion, then the potential energy plus the kinetic energy at the top is equal to the kinetic energy at the bottom of the hill, and vice versa. Let's look at one more conceptual example of conservation of energy. The potential energy of a cliff diver at the top of a cliff relative to the water below is equal to the kinetic energy of that same cliff diver just before they strike the water below. The next lecture video will go through some conservation of energy calculations.